All right, and we're live. So, good morning, good afternoon, good evening to all of you, wherever you are in the world. Thanks for tuning in to this June live stream for live session, this live workshop actually for June 2022. We're really happy that you're here. So, we're here with Nitin Joyce today, one of the instructors on AppSecEngineer, and he will be showing us attacking and defending container registries. So, over the next hour or so, he'll be showing you how to attack AWS ECR and ECS, Trojanizing and backdooring container images, and he'll also show you some defensive techniques, by securing container registries with Harbor, building container security pipelines with GitLab and GitLab Registry. So we've actually got a ton of content for you today, and we can't wait to get you started. So take it away, Nitin.
Thanks so much, Anish. First of all, welcome, folks. Super excited to have you here. So, this is going to be a live workshop. So, you are going to be accessing our entire lab platform in order to be running some of the labs with me. And Anish will be going ahead and sharing the sign up link. So, what I'm actually going to do is I'm going to go ahead and send you the link real quick. And if you can just, put it on the chat, that will be super helpful.
Sure.
So you can go ahead and sign up for that to get started. And all the labs that we are going to be running today, you're going to have access to it for like a week or so, right? So you're going to have a complete access to all of the labs. And even if you want to go ahead and run some of these labs at a later point, you can go ahead and do that. So with that, let's quickly get started. So the agenda of this course is, or this workshop is essentially going to be a quick introduction to container registry. Now, we're going to be going in depth, and we actually have a course coming out very soon on AppSecEngineer. So, if this is the sort of content that you find interesting, please be sure to go ahead and subscribe to AppSecEngineer. But this is a brief version of what the entire course is going to look like. And I've essentially handpicked a few of the labs that we have as part of the course, and we're going to have a workshop around it. And I really hope you find us helpful. So with that, let's quickly get started. I'm going to go ahead and essentially share my screen, and I'm hoping the slides are visible. So again, welcome to an introduction to container registries. My name is Nitin Jewis. I'm one of the senior research officers at AppSec Engineer, and also one of the trainers on the AppSec Engineer platform as well. So in today's workshop, we're going to start off with a very brief introduction of container registry. First of all, why are container registries even necessary in the first place? And what are some of the features or the security features and functionalities that container registries typically provide? And once we do that, we're going to go ahead and actually attack a live implementation on ECR, which is the AWS Elastic Container Registry. We're going to go ahead and perform an attack on that by Trojanizing a Docker image and pushing it to a registry and pretty much gaining complete access to the AWS infrastructure. So we're going to show you how dangerous a misconfigured container registry can be. And finally, once we're done with that, we're going to look at some of the defensive mechanisms on how you can go ahead and start securing your container registry. So with that, let's quickly get started. So a container registry is essentially a place to store and distribute images, right? So typically when you have Docker images, they are usually built using Docker files. Now, instead of having to distribute all of these Docker files and having multiple users in the organization build the entire Docker image every single time, it made a lot of sense for you to go ahead and build a Docker, the entire Docker image, store it in a repository somewhere so that everybody else who needed access to that particular Docker image could just go ahead and pull it and get the application or the service up and running. Now, container registry typically is going to store your container image layers, right? So if you don't know what container image layers are, we do have a course called Introduction to Containers. I would highly recommend that you check it out, where we go in depth on what these layers are, the functionality of it, and what they typically do as well. And finally, the container registry are OCI compliant as well, which is the open source container initiative compliance. So typically a container registry is going to be a repository, right? So a repository where you're going to be storing all of your images, for example, right? So you can also store your images, or if you happen to use something like Kubernetes, for example, some of these container registry also allow you to store Helm charts, right? So you can go ahead and store Helm charts as well. Then most of these container registry are OCI compliant, which is the Open Container Initiative. So they're going to be compliant to that. And one of the other key functionalities of some of these container registry is that they have build and deploy triggers. Right. So what this would essentially mean is you can go ahead and connect your container registry to your GitHub repository or to your GitLab repository, so that every time there is a commit or a change that is made on that particular code repository, your container registry can go ahead and it would keep watching your code repository. It would trigger a build and it would go ahead and essentially build the entire Docker image based on the Docker file that has been stored as part of the Git repository. Now, additionally, you can also leverage some of these container registries for continuous deployment as well, right? So what you could do is you could go ahead and once an image is built and once it's pushed into the container registry, that could in turn trigger an additional webhook, which would then go ahead and deploy the latest version of the image onto the target environment, whether you're using Kubernetes or Fargate or any other container orchestrating system. You can go ahead and deploy it automatically. Now, typically, all of these container registry do support storing images with tags, right? So typically, you would go ahead and have a tag for your particular image, and you can go ahead and sign some of these tags as well, right? So I'm sure you folks have heard of Docker sign, where you can go ahead and sign a particular Docker image. Well, technically, you're not signing the image, you're actually going ahead and signing the tag. So you can have signed and unsigned Docker images or tags. Additionally, you can also have policies in place, right? So if you want some sort of access control or role-based access control, or some sort of policies in place where a certain target environment, only those particular set of environments are allowed to pull Docker images from the container registry, you can go ahead and have granular controls with regards to the permissions of the container registry and how it would typically work and perform. And finally, and importantly, it also supports for scanning your images as well. So let's say you're going ahead and storing 10 or 20 images on your container registry. Now, typically, you would want to go ahead and have scheduled scans, which is going to constantly go ahead and scan all of your Docker images or your images for known vulnerabilities, right? So some of these container registry, they do integrate with multiple scanners out there, and they go ahead and scan your images that are being stored every time a new image is pushed, or you can go ahead and schedule some of these scans as well. Now, when it comes to container registries, there are multiple types of registries. Now, first of all, when you look at the operation, right? So if you want to go ahead and have a managed registry, you can opt for something like ECR, for example, right? So you don't necessarily have to worry about the underlying infrastructure or the storage component of the entire registry. It's all of it is taken care of. Or if you want a self-managed registry where you want to go ahead and deploy your own container registry on a server that you own, you can go ahead and opt for something along those lines as well, right? So typically speaking, an example for self-managed container registry would be something like Harbor, which is an open source project. And for managed registry, it would be something like Docker Hub or AWS ECR as well. Then you also have pricing, right? So if you want to go to the commercial variant, where typically for something like AWS ECR, you would have to go ahead and pay a certain sum of money in order for you to be able to store images and scan images and so on. Or if you want to go ahead and opt for an open source project, you can go ahead and deploy it on your own environment, and you can essentially use that for free. Then we also have the entire visibility of the container registry, right? So do you want it private inside a private network or inside a private VPC, which is not necessarily exposed to the public internet inside your own network or infrastructure. Or if you want a public container registry where you're going to have multiple people who are going to be downloading the images that you have on your registry. If you want it for public consumption, you can go ahead and deploy a publicly accessible container registry as well. And finally, we also have deployment, right? So you have a cloud integrated or uh, cloud provider based deployments like something like ECR, or you can also opt for third party deployments and go ahead and choose that as well. Now, typically speaking, container registry by default, at least most of them, do have a bunch of security features, right? So let's quickly go through some of these security features, and then we're going to be looking at attacking container registries very soon as well. So, first of all, one of the key security features is going to be auditing, right? So, if you want to go ahead and keep a track of all the operations that are being performed on the repository and you want to keep a track of it through logs, some of these container registries, they do provide the auditing capability. Then if you want tag immutability, right, so you can go ahead and actually create a policy that will help you create immutable tags. Then you have multi-tenancy. You can either do it for projects or you can also do it based on something like role-based access control. Then we have quotas, right? So if you want to go ahead and specify a storage limit for certain set of accounts, you can go ahead and set project quotas in place, because one of the key issues that people often tend to run into, especially when they're managing their own container registry, is running out of space, right? So if they have like a ton of container images that are being stored, and all of these images are fairly heavy in terms of size, then you can run out of storage capacity fairly quickly. In such scenarios, if you want to go ahead and have project specific quotas in place, you can go ahead and set that up. Then you have something known as image signing, right? So, for example, Harbor uses Notary in order for you to for image signing and so on. Additionally, you can also have policies in place which would essentially prevent unsigned images from being pushed to the registry. Thereby, you can go ahead and increase the overall security of the images that are being stored, right? So, by signing images, you're essentially verifying that the actual owner is signing the particular image tag and only then pushing it to the registry, and it's not some malicious actor or an attacker who's doing it. So, in such scenarios, you can have policies in place where you can enforce signing some of these Docker images, and only the signed Docker images, which can later be verified, can then be pushed to some of these Docker registries. Then we have image scanning, right? So as soon as you push an image to a container registry, if you want to go ahead and run a quick scan on top of it, you can go ahead and do that. If you want to, if you want to have scheduled scans every week or every once every 2 days, if you want to go ahead and schedule some of these scans, you can go ahead and do that as well, right? So image scanning is going to be one of the key security features across some of the container registry. And finally, it also allows you to create robot accounts or service accounts. Now, typically, you would want some amount of flexibility in terms of automation, right? So, whenever you're using some of these container registries, in such scenarios, you can go ahead and create accounts for your CI tool. If you're using Jenkins, you can go ahead and create a essentially a token for Jenkins or an account for Jenkins, so that as soon as Jenkins goes ahead and builds an image, it will automatically be able to push it to the container registry. Or if you are using GitHub Actions or GitLab CI, you can go ahead and create robot accounts or service accounts such that they have the permissions to go ahead and essentially push images onto the container registries and so on. And even Harbor supports as a creation of robot accounts and so on. So with that, let's quickly go over some of the examples of container registries, again, we're going to be going in depth on all of these topics in our course, which we are going to be launching very soon. So if you want to, essentially keep an eye on that, go ahead and subscribe to our accounts on social media. I'm sure Anish will be sharing our Twitter account and the LinkedIn account on the YouTube chat or the live stream chat very soon. But go ahead, if you want to keep yourself updated on some of the courses that we are going to be launching very soon. And we do have a bunch of courses that we've planned for the next couple of months. So coming back, right? So the first container registry which we are going to be looking at is Harbor. Now, Harbor was first of all created by VMware in 2014, and I think sometime in 2018 it was donated to the CNCF. And this happened to be one of the first container registry projects that was graduated by the CNCF. Now, one of the key features of Harbor is that it has both a GUI as well as an API, right? So if you just want to leverage the CLI tool and access and configure and use Harbor, you can do that by leveraging their APIs. Or if you're more comfortable accessing the user interface and want to go ahead and use the container registry with that, that is something that you can opt for as well. And since it has APIs, it also makes it extremely easy for third party services or applications to essentially go ahead and integrate with Harbor. And finally, Harbor is OCI compliant, right? So it's an OCI compliant cloud native artifact registry, and this supports OCI artifacts, right? So it can go ahead and support container images, and it can also go ahead and support Helm charts now that it has moved towards OCI compliance as well. So with that, let's go ahead and look at some of the key features of Harbor first, and then we're going to be doing the same for ECR as well, right? So, and this will help you get a good comparison, and it can help you decide if you are trying to choose between something like Harbor or ECR. Within the next couple of minutes, you're going to have a good understanding of some of the features of Harbor and some of the features and functionalities of AWS ECR as well. So when you look at some of the features of Harbor, first of all, it is a cloud native registry, right? So it supports storing both images as well as Helm charts. And it also allows for replications, right? So if you have images or chats and you want it replicated between multiple registry instances, you can go ahead and do that as well. Now, one of the reasons I personally like Harbor a lot is it's extremely easy for you to get it up and running, right? So deploying Harbor is like extremely easy. It's just a Docker Compose file if you're not really looking at scalability all that much. And you can simply go ahead and deploy it, and you can essentially get it up and running in less than 10 minutes or so. Additionally, it also has support for OIDC and LDAP. So if you're an enterprise, if you want to go ahead and integrate it with any sort of external authentication system, you can go ahead and leverage the OIDC and LDAP support. And finally, it also supports multiple webhooks, right? So it whenever an image is being built, or whenever as soon as an image is built and stored and scanned, you can have multiple webhooks that are configured, and it's extremely easy to keep yourself notified. So let's quickly go over the Harbor architecture fairly quickly. And then we're going to be looking at some of the third-party integrations that Harbor supports. And again, we're going to go back to ECR and look at some of the features and functionalities of ECR as well. Now, first of all, Harbor, it does have something known as the API, or the proxy API routing. This essentially runs on top of Nginx, and Nginx is going to be responsible for routing to different or various endpoints that it has. Then you have something called the core component, right? So the core component is going to have the API server, it's going to have the API controllers, it's going to have the configuration manager, the signature manager, so on and so forth. The core component, everything that is currently in blue, is going to be the main heart of the entire Harbor, right? So this is where all of the core functionalities of Harbor come in. Then finally, we have the log collector, right? So previously we spoke about how auditing capability is one of the key security features in any container registry. Now, the log collector is going to be responsible for collecting all the logs that essentially happen on Harbor. Then we have the data layer where we have Redis, right? So we have Redis and we have a SQL database and so on. Redis is going to act as a cache for all of the project metadata. Then we also have local storage where all of the artifacts are stored. And then we have Postgres, which is a SQL database where information about all of the project details are going to be stored. Now, additionally, it also has integrations with various scan providers, right? So some of the ones that we see on the screen are Claire by the CoreOS team. Then we have the Trivi, which is by the Aquasec team. Then we have Anchor, which is another good scanner. And we also have a tool called DoSec. And additionally, if you want to go ahead and have replications across multiple other container registry, right? So let's say you're storing your images on Harbor, but you also want replicas across multiple places. It supports integrations with multiple other container registries as well, right? So whatever image is on Harbor, the same replica can be stored on multiple other registries such as AWS ECR, Azure ACR, Google GCR, Docker Hub, GitLab, who has their own container registry, Artifactory, and so on. So one of the things that you will probably observe is Harbor has a ton of integrations right out of the gate, which makes it extremely flexible for you to configure it the way you want it, and you can go ahead and get started almost immediately. Now, when we look at some of the third-party integrations, right? So these are some of these services that support integration with Harbor. So if you look at OIDC, it has support with Google, Keycloak, Dex, and Ping Identity. Similarly, like I previously mentioned, if you want to go ahead and start creating a replication of images, you can do it on Docker Hub, GCR, ECR, ACR, Artifactory, Quay, GitLab, and a bunch of other container registries. And finally, if you're looking for scanner integrations, if you want to go ahead and ensure all the images that are being stored on Harbor are scanned, you can go ahead and integrate multiple scanners, right? So a few examples that we have here are Claire, Trivi, Anchor, Sysdig Secure, Tensor Security, ArcSec, and so on. So these are some of the scanner integrations that are provided. Now, with that, let's quickly look at ECR, and that should give us a good comparison, right? So ECR is a fully managed container registry provided by Amazon, and it makes it extremely easy to store, manage, share, deploy container images and artifacts anywhere, right? So you can go ahead and store all of your container, especially if you are within the AWS ecosystem. The integrations that are provided by ECR and the ease of use is almost unmatched. And finally, it eliminates the need of having to deploy and maintain your own container registry service, right? So all of those bottlenecks, all of that hassle is taken away. You can go ahead and leverage Amazon's infrastructure to start storing and using all of your Docker images from there. Now, Amazon ECR typically works with Elastic Kubernetes Service. It works with ECS. It works with Lambda, Code Pipeline, Lightsail. You can go ahead and spin up your containers using Lightsail, Code Build, Fargate, and so on, right? So it integrates with a bunch of services that AWS provides, and it is also extremely easy for you to go ahead and start integrating across all of these services as well. And the additional benefit is obviously the access control that's provided, right? So if you're using AWS IAM for access control, you can go ahead and essentially build access control for ECR on top of it, which makes it easy for you to go ahead and manage permissions and so on. So with that, let's quickly look at some of the benefits of Amazon ECR. Right. So first of all, it integrates with your container orchestrating system. It also is compliant with OCI, which is the Container Initiative, and it supports for Docker. You can have public container images and artifact galleries, right? So you can go ahead and do that. If you want to go ahead and distribute some of the images that you're storing on ECR publicly, AWS ECR allows you to do that. Additionally, it has a bunch of third-party integrations via the marketplace, and obviously it has high availability and durability. Additionally, it also provides for team and public contribution. You can build access control on top of it by leveraging the IAM, like I previously mentioned. You can start encrypting all of your images using KMS, the integration that provided. Third party integrations through the marketplace, you can go ahead and do that. And finally, granular security permissions with AWS IAM is something that you can go ahead and do as well. Now, when you look at ECR public or the public registry, on the other hand, this is typically going to be the public registry, the repository, and the images as well. Now, this is going to be very similar when compared with ECR in terms of features, except the fact that all of the images that are going to be stored can be pulled publicly, right? So this is typically going to be used for public consumption if you want to go ahead and distribute all of your Docker images for your clients and customers. Authentication is obviously going to be necessary whenever you want to go ahead and push your particular Docker image onto the private repository. You can authenticate via passwords, or you can also use token based authorization token based systems as well. And finally, you can go ahead and start pushing your container images, whether it's Docker or any other OCI compliant image, to the public repository. And you can go ahead and push your Helm charts as well. So with that, let's actually understand ECR hierarchy and quickly get into the very first attack of the day. So typically your ECR registry is going to have multiple repository, and each of these repositories can have several tagged or untagged images, right? So this is typically how it's going to work. You're going to have your registry. Inside your registry, you can have multiple repository, and inside your repository, you can go ahead and have multiple images that are being stored. Now, on the registry level, you have features such where you can go ahead and authenticate to the registry. If you want cross-account permissions for the registry, you can go ahead and do that. If you want cross-account or cross-account replication permissions on the registry level, that is something that you can go ahead and configure as well. On the repository level, you can have repository IAM and repository policies, right? So if you want to have policies in place on the repository level, that is something that you can go ahead and build. If you want replication across regions for multiple accounts, you can go ahead and do it on the repository level. Obviously, this is going to help you store multiple images and tags. And on the repository level, you can also enable encryption. So all of the images that you are going to be storing within that particular repository, you can go ahead and encrypt them. It also provides a functionality called scan on push. Every time you go ahead and push an image onto a repository, it can go ahead and scan it for known vulnerabilities automatically. And finally, it can also have immutable tags. And finally, on the image level, you can go ahead and have lifecycle policies in place. If you want to go ahead and encrypt only certain set of images, you can go ahead and do that as well. Additionally, if you want cross-region or cross-account replication for specific images, you can do that. And if you only want to scan certain set of images and not the entire repository, which is going to have multiple images, you can go ahead and scan specific images as well. So on a very high level, when you look at some of the security features of ECR, first of all, you have IAM access policy and repository policy. Then you have the lifecycle policy, where for a certain period of like after a certain period of time, if you don't want to use a particular image, right? So you can say every quarter the image has to be rebuilt. If it's more than a quarter old, it should not be essentially accessible or being pulled from some other place. You can go ahead and set in life cycle policies in place. You obviously have image scanning, which can be enabled. It also allows you for cross account and cross region replication of all of the images. And finally, if you want to start monitoring all of the events on ECR, you can go ahead and enable CloudTrail. So with that, let's quickly go ahead and get started with the attack. So in the attack, which I'm going to be running, again, Anish can go ahead and share the AppSecEngineer sign up link with you folks on the chat. Be sure to go ahead and sign up for it. You are going to have access to the entire lab environment for a week, so you can go ahead and run it. If you have a subscription of AppSecEngineer Pro, you can use our AWS Sandbox environment for you to go ahead and run all of our AWS labs. But if you're on a free trial account or if you're just signing up for this, you will have to bring your own AWS credentials, right? So the lab which I'm going to be running as an attacker, I'm going to be Trojanizing a Docker image. I'm going to go ahead, Trojanize a Docker image, and I'm going to go ahead and push it to the container registry. In our case, it's going to be ECR. Now, whenever a target user or a victim pulls my particular Trojanized Docker image and runs my particular image, I'm going to have complete access to that particular system. I'm going to have reverse shell access through which I can go ahead and start accessing the environment of the target user or the victim, right? So I'm going to be running this lab and we're going to be running this attack on AWS ECR. Now, if Trojanizing containers is something that you're not very familiar with, uh, on the AppSecEngineer YouTube channel, I've made a separate video on how you can go ahead and Trojanize your Docker images. So be sure to go ahead and subscribe to our YouTube channel. And there's a ton of content which I'm sure you'll find helpful. And Trojanizing container images is one of them, where I go in detail on how you can go ahead and start Trojanizing container images. So with that, let's go ahead and compromise AWS ECR, right? So once you log in, this is the screen that you should be at, right? So once you go ahead and select your course, which is going to be Introduction to Container Registry, the lab that I'm going to be running is compromise AWS ECR. So let's go ahead and quickly get started with the lab. I've gone ahead and I've completed the deployment already. So if you've not, you're going to have to do AWS configure and all that. So step 1 to step 4, it usually takes some time. So I've gone ahead and done that. Now that my application is deployed, I can simply run the echo command and I should ideally be able to access my application that's running. In here, I have an email ID where I can simply go ahead and say nitin.joes at v45.com. I can hit subscribe and it's going to go ahead and respond back with a weird response, right? So it's going to tell me 301 moved permanently. Now what I'm going to do is I'm going to try and see if I can fire a payload, right? So far, it looks like it's gone ahead and actually accessed at v45.com or at whatever it was, and it's returning the response. So what I'm going to try and do is perform a server-side request forgery attack. Now, typically, whenever you deploy something on an EC2 instance on AWS, it's going to have the metadata endpoint, which is usually going to be running on 169.254.169.254. Now, through the metadata endpoint, you can go ahead and fetch the role which is attached to that particular resource. And you can also go ahead and fetch the credentials as well, which is what I'm going to do. So first of all, I'm going to go ahead and I'm going to fetch the IAM details. And within the IAM, I'm going to try to fetch the security credentials, right? So I'm going to go ahead and essentially in here, I'm going to fire a payload which says, I want you to access the metadata, IAM, and security credentials. And as soon as I do this, it's going to give me that there's a rule called customer rule that has been attached to it. So let me go ahead and try to access that real quick. And all of a sudden, it's gone ahead and given me the access ID, the secret key, and the token as well. So I'm going to copy this entire thing. And the next thing I'm going to have to do is I'm going to go ahead and as an attacker, I now have access to the security credentials of the victim, whoever is running this application. Now, using these security credentials, I can go ahead and run a bunch of tools and essentially figure out that they are using ECR internally. So what I'm going to do right now is I'm going to go ahead and export all of these credentials. So on my personal machine right here, I'm going to open up a code editor real quick. And I'm just going to go ahead and copy the things from my application, whatever the response was. I've gone ahead and copied it. And now I'm going to very soon start storing it as environment variables, right? So I will need the access ID. I will need the secret access key. And finally, I will need access to the token as well, right? So I'm going to go ahead and essentially ensure that I have all of these things. And I'm going to copy these export commands onto my code editor as well. So I've gone ahead and I've copied the access ID. I'm going to do the same for the secret access key. So bear with me for 1 second. Should be done very soon. And finally, the same for the session token as well. So I'm going to copy the credentials that I just stole uh, as on my code editor. I'm going to quickly go ahead and start storing it as a environment variable on my lab instance. All right, so with that done, I'm going to go ahead and come back to my lab instance, clear the screen real quick. I have my access ID, I have my secret key, and I have my session token as well. So I have all of those details stored as environment variables. And now I can use STS get caller identity to verify my new credentials that I just stored. Right. So I can go ahead and run this and verify if it works. And it tells me that, hey, you know what, this is a customer role, which is the credentials of the role that I just stole. Finally, I'm going to do AWS ECR describe repositories. And looks like there is a repository right here, right? So my goal as an attacker is to go ahead and log into the repository since I have access to it right now with the credentials I just told, and start pushing in Trojanized images onto that registry. So I'm going to go ahead and store repository URI as an environment variable so that it makes it a little bit more easier for me to log in and perform or run a bunch of other commands. And finally, I'm going to say AWS get login password, and then I'm going to say Docker login, right? So with that, my Docker instance right now has been logged in to the ECR based on the credentials that I just told. Now what I can do is I can start pulling the images that already exist on the registry, right? So I can go ahead and pull in my Docker image, which is currently stored on the repository right there. So this is going to go ahead and pull the image for me. And once my image has been pulled, I'm going to be leveraging an open source tool called Docker Scan in order for me to go ahead and Trojanize this particular image. Right. So I'm going to go ahead and Trojanize this image with Docker Scan, and then I'm going to go ahead and push it back to the registry using the credentials I just stole. So once I've pulled in the image, It's also stored to a file called ASE Flask. Right, so I'm going to have a file here called ASE Flask. I'm going to feed that file onto Docker scan, and I'm going to modify that particular image by Trojanizing it. And as soon as I Trojanize it, it's going to give me a netcat listener command. Right, so this is the command that I would typically run. And as soon as a victim runs my Trojanized image on their target environment, I would get complete reverse shell access to it. So finally, once the image is loaded, I will go ahead and if I perform Docker images real quick, I can see that there are two images. This is the Trojanized variant. I'm going to go ahead and push this latest image onto the target registry. Right, so it's going to go ahead and push it onto the target registry. And you can also, so the old one, right? So renaming the old one with ID to empty string, right? So this was the old one and it's gone ahead and the tag is now an empty string. So finally, once that is done, I'm going to go ahead, open up a new terminal and run a netcat listener on the lead port, right? So I'm going to be running a netcat listener on the lead port. And finally, once that is done, I'm going to navigate to compromise ECR. I think I'm in that directory already. But with that, I'm going to go ahead and I've also set up an EC2 instance, right? So I've already gone ahead and set up an EC2 instance. So as a victim, what I'm going to do is I'm going to SSH into that particular EC2 instance, and then I'm going to go ahead and essentially pull in the that particular Docker image and run it. So what I'm going to do is I'm going to SSH into my particular EC2 instance real quick. Yes. And I'm going to be inside my EC2 instance, which was deployed as part of my Terraform deployment as well. And finally, in here, again, I'm going to go ahead and essentially log in to my private registry real quick, or to my container repository. And once I do that, I can go ahead and pull in the latest image. But this time, if I'm going ahead and pulling in the latest image, it's going to be the Trojanized variant, right? So this is going to have to be the Trojanized variant, which I previously pushed. So if you want, you can go ahead and compare the tags by running Docker images right here, and it's going to be the same, right? So we've gone ahead and essentially pulled in the Trojanized variant of that particular Docker image. So we can confirm, hopefully, by running Docker images, if I can spell Docker right. Right, so it's going to be this one right here, which was created 54 minutes ago, technically. So once that is done, I can go ahead and pull in the latest version of that particular image, which I previously did. But it looks like it's not the none tag, right? So, which is weird. Anyways, so finally, I can go ahead and try to run this particular image of mine. So if I do Docker PS, if there's a container, I'm going to go ahead and stop it. So I'm going to go ahead and stop this container. Not sure what happened. It looked like my lab timed out at the last moment. So typically what would happen is as soon as I go ahead and do this, and as soon as I run this particular image, right? So I would go ahead and get a reverse shell access onto the netcat listener that I had signed up. And from there, I will have complete access to the AWS infrastructure, and I'll be able to gain access to multiple other things as well. Right. So again, you will have access to this lab. So go ahead, run this lab. If you run into any hiccups, I think I did a mistake by prematurely running the lab and configuring a few things to save a few minutes. But it should still go ahead and work fine for you folks. And once you do run the lab, do let us know in the comment section below on how it goes. So with that, I'm going to go ahead and continue anyway, instead of me wasting time running the lab again. But on a very high level, that is what has happened. From an intentionally or a vulnerable application, I was able to perform SSRF. From there, I was able to steal credentials. Using the credentials, I was able to perform reconnaissance and figure out that, hey, you know what, this particular set of credentials have access to ECR. Using those ECR credentials, I was able to pull an image and also figure out that these credentials do provide the permissions for me to push an image. So from by pulling the image, I was able to Trojanize it and push the Trojanized image back to the container registry. Now, whenever a victim or an end user runs that latest version of the Trojanized image on their environment, on the netcat listener, as an attacker, I would end up getting complete reverse shell access to it. So on a very high level, that is how the attack is going to be working. But with that, let's go ahead and quickly look at vulnerability assessment. Right. So when you look at vulnerability assessment, it's going to be important for a bunch of reasons. First of all, a good vulnerability assessment tool is going to help you identify threats and the risks that those threats possess. Additionally, it's also going to classify the vulnerabilities it finds based on different types, right? So whether it's a OS level issue or a non-OS level issue. And it some of these tools, they also give you a risk score or the severity score, using which you can go ahead and start prioritizing some of those vulnerabilities that have been found. Now, additionally, most of these tools, they do provide remediation recommendations with regards to how you can go ahead and start fixing some of these issues. They obviously provide reports that you can go ahead and export, use, and leverage. And finally, most of these tools, they do provide very good CI/CD integrations as well. But obviously, there are going to be a few limitations when it comes to these tools, right? So findings depend on the vulnerability score, right? So it's going to have based on the vulnerability source, right? So depending on the database that this tool is using, only based on that your findings are going to be good, right? So if the backend database that this particular tool is using is not great, obviously the findings that it's going to have is not going to be great as well. Additionally, these tools don't necessarily find sensitive information, right? So if you have hard-coded secrets or credentials or API tokens, it's not going to be able to find any of this. And finally, it's not going to be able to scan for malwares, right? So just like our previous example, if I go ahead and Trojanize an image, and if I try to scan it using a VA tool, it's not going to be able to find it. And finally, it's usually is not going to have SaaS support, right? So if you are going to have an application container where you've written an application in either Python or Node.js or Golang or any other programming language, it is not going to be able to scan your source code for you, typically. Now, obviously, there are a bunch of open source tools that are available. We have Claire by the CoreOS team, which is a great tool. We have Dagda, we have Anchor, which is another great tool. Then we have a tool called Docker Bench. Docker Bench is not necessarily for scanning images. It's more to do with essentially scanning how you've set up your Docker installation itself, right? So it's going to go ahead and have a few compliance checks and verify if the Docker engine that you're using itself is secure. Then you have Trivi, and I think a few months ago, Snyk also partnered with Docker, and you can start running Docker scan from the Docker CLI itself. So that is something that you can go ahead and leverage as well. But one of the labs that we are going to be looking at is scanning images as part of CI. And this is something that you can do by leveraging some of these open source tools as well. Right. So the next lab, I'm going to close this one. The next lab is going to be GitLab CI scanning. Again, you can go ahead and run these labs. The instructions and the audio instructions are going to be available as well. I've gone ahead and run this lab already, so I'm just going to quickly show you how it all works. So typically what you would do is you would go ahead and import a repository from our GitHub, where we have the GitLab CI that has automatically been set up. So we'll quickly go over the GitLab CI, and then you can go ahead and essentially trigger a pipeline, which would build an image, store your Docker image on the GitLab container registry, and then it would go ahead and scan your image as well. So in here, let's quickly go over the GitLab CI file. I went ahead and ran this lab, I think 20 minutes before we got started with the workshop session. So in here, I have two stages, right? So I have the build stage and I have the scan stage. In the build stage, I have the repository right here, which also has a Docker file that I'm using, right? So there is a Docker file that I have right here. So it's going to go ahead and first of all log in to the GitLab container registry with the username and password, which can be accessed through the injected environment variables. And once that is done, it's going to go ahead and build my image. And once the build has been successful, it's going to go ahead and push the container image onto the GitLab registry as well. So this is part of the build stage. Now in the scan stage, I have a bunch of scanners that we've gone ahead and integrated. First of all, I'm using a tool called HedoLint, right? So HedoLint is more of a lint checker for the Docker file that you're using, right? So if you want to ensure that the Docker file that you're using is first of all secure and well written, you can go ahead and leverage a tool like HedoLint. Then I'm going ahead and leveraging a tool called Claire. Right, so I've gone ahead and leveraged a tool called Claire by the CoreOS team, where I go ahead and install Claire. And once I've done it, I'm going ahead and running a scan against the image I just built. Now here I'm actually going ahead and going to the next step. Even if the tool happens to find vulnerabilities, I'm just going ahead and passing this particular job as successful. But typically what you would do is identify high severity flaws, and potentially if you want to do it, you can go ahead and fail the build as well. So in here, I've gone ahead and integrated Claire. Similarly, I've gone ahead and integrated a tool called Anchor, right? So which we previously spoke about. So I've gone ahead and I'm running a scan by leveraging a tool called Anchor. And all of the reports that I'm creating, right? So all of the reports that these tools are generating, I'm going to go ahead and store them for a week. And this is flexible, right? So if you want to store it for a longer period of time, you can absolutely go ahead and do that. And finally, I'm also using Trivi, which is another open source tool, which is extremely easy and very fast in terms of running a scan, especially if you want to run it as part of your CI. So if you have to choose one tools out of all the ones that I've mentioned, uh, I would probably recommend something like Trivi, uh, because the scans are a lot faster. You can go ahead and filter out the reports and look for only the high severity and the high confidence ones and so on, right? So this does have additional functionalities which are available. So I've gone ahead and run a scan using Trivi. And again, I'm going to be storing all of the results as artifacts for a week as well, right? So if you go back to the pipelines, and if you look into this particular pipeline, and across all of these jobs. So the first one is the build phase. Then in the scan phase, we have anchor scan that is done. And if you want to go ahead and browse or download the artifacts, you can do that. Similarly, we have the Trivi scan that has run. So if you quickly want to go ahead and browse through the result file that's been generated, it's going to be in JSON format. Uh, it's going to tell me that there's a critical flaw that's been found and so on, right? So it's going to give you detailed information along with remediation recommendations and so on. And finally, if you want to go ahead and look at the registry, you can head over to the container registry and look at the image that was built, right? So I published this image approximately 1 hour ago. So if you want to go ahead and pull this particular image, you can go ahead and copy the Docker pull command. And once you log in, you should be able to pull all of the images. So essentially, in this example, we are building the image. As soon as there's a commit, we're going ahead and building the image. We're scanning a Docker file and we're running a bunch of scans on the Docker image that has been built as well. Now, by doing this, you can get a good idea whether the image that you are using is secure or if it has some of the known vulnerabilities as well. But the other thing is some of these registries, they do provide scanning capabilities, right? So if you want to go ahead and scan images on Harbor, it does give you the ability to do that. So all the scanners that we previously saw, like the Claire, the Anchor, and the Trevi, Harbor does provide you integrations where you can go ahead and integrate these scanners and quickly run a scan directly on your registry if you do not want to do it as part of your CI process. Additionally, if you want to do it on ECR, that's something that you can do as well. So Harbor essentially uses Tribby or Claire, and it's going to be performing a static scan on the image. Now, Harbor does have a few additional features as well, right? So you can go ahead and add additional scanners like Anchor if you want to do it. If you want scheduled scans, that is something that you can do as well. You can go ahead and start scheduling scans on Anchor and run scans every week. Or if you want to have a CVE allow list, right? So we figure out there is a false positive based on the results that are being generated, and you don't want these false positive reports to come up in the subsequent scans. You can go ahead and have an allow list in place so that in the subsequent scans, those results don't pop up. So with that, let's quickly go ahead and run our Harbor image scanning lab. So I'm going to close all of these things, head over to Harbor image scanning, and I'm going to go ahead and provision a lab for myself. Right, so I'm quickly going to go ahead and provision a lab. So in this lab, we're going to be setting up Harbor from scratch. So you'll get an idea on how easy it is to go ahead and deploy it, right? So it's fairly easy to go ahead and deploy Harbor. So we're going to go ahead, deploy Harbor, perform a Docker login onto the Harbor registry, push an image, and also automatically scan the image as well. All right, looks like my lab instance should be up and running. So first of all, I have to make a few configuration changes to harbor.yaml. Now, obviously, this is a lab, right? So this is an example lab. You would not want to do something like this in production, where you're giving an IP address and replacing it and generating certificates based on the IP. Typically, you would have a domain, and then you would go ahead and essentially generate certificates for the domain. But in this example, we're just going to leverage the IP address. So I'm going to go ahead and make a quick configuration change to the Harbor configuration file that we have. And I'm going to add the IP address, my server IP address, to the OpenSSL configuration. So this is the command that I'm going to be running, right? So I'm going to say, I'm going to insert subject alternative name IP, and I'm going to give it the server IP address, which I just got in openssl.conf. So I'm going to go ahead, copy this command. I am going to have to replace the server IP right here. So please be sure to do it. Otherwise, the lab is not going to work. So I'm going to copy my IP address, paste it right here, and hit enter. So that should go ahead and insert a line with this configuration, which I just set. And finally, I can go ahead and start generating my key with using OpenSSL. So here it's going to tell enter random values, but enter your server IP address when it's going to ask you for your common name, where you can go ahead and give your server's fully qualified domain name or your IP address. So in here, it's going to ask you a bunch of things. Country name is probably going to be IN. I'm just going to give it the same values. Really does not matter. ASC for AppSecEngineer. ASC again. In here, I'm going to have to give it my IP address, right? So it's going to ask me for my server FQDN or the common name. I'm just going to give it my IP address. I'm guessing this is optional, but I'm just going to say if I can spell my email address right, and it should be done. Right, so I have my certificate and my key, which has been generated. Now what I'm going to do is I'm going to go ahead and add all of these certificates under Docker daemon. So I'm going to go ahead and first of all create a directory with my server IP, and I'm going to store all of my, or I'm going to copy all of my certificates there. So I'm going to create a directory. So if I say ls etc docker certs.d, there should be a subdirectory with my IP address and a port wherever my registry is going to be running. So I'm going to copy domain.cert as the CA cert. And then I'm going to go ahead and perform a Docker reload, right? So I'm going to go ahead and restart Docker on this particular instance. Now, finally, once this is done, I'm going to have to replace the path of wherever my container is, or wherever my CA cert is with the Harbor in the Harbor configuration file, right? So here it says your certificate path and private key part that was generated, go ahead and with your private key part, go ahead and replace the values, right? So I'm going to have to do that. So typically what I generally do is I copy these commands in a scratch file. Uh, Essentially makes it easy for me to go ahead and edit it, because sometimes what does happen is as soon as I copy it and paste the command, it's going to go ahead and execute it, which can be pretty problematic. So in here, it's asking me for my certificate path and my private key part. So both of my certs and my private keys are going to be available within Harbor, if I remember correctly. What's in the root directory itself? I see them right here, right? So it's right here. So if I do an ls, I have and do a pwd, they are present in the within the root directory. So I'm just going to copy the certificate name real quick, which is going to be domain.cert, and it's going to be /root. I should actually be able to run these directly. It's a set command. So it's going to replace your certificate path with root domain.cert. I thought I had to replace the value with the other ones. And domain.key is right here as well. I can simply run this, run it. And if I want to verify, I can head over to Harbor, click on Harbor YAML, and verify if all of it is done, right? So I have my certificate path available right here. I have my private key part available right here. External URL, all of that has been taken care of as well. Host name, it's been replaced. So far, it looks like my Harbor configuration file is good. So with that, I'm going to have to navigate to the Harbor directory, and I'm going to have to essentially create a Docker Compose file for myself. So what I'm going to do is I'm going to say I wanted to prepare a Docker Compose file, but I'm going to say I want it with Trivy and Chart Museum, right? So this prepare file is automatically going to go ahead and is going to create a compose file for me. So I'm going to say I want it done with Trivy. So it's going to pull in all the necessary images, and it's going to go ahead and create a compose file, which I can quickly go ahead and launch. And once it has been prepared successfully, I can go ahead and install it as well. And by doing this, it's going to go ahead and spin up Harbor, my entire registry, with Trivy and Chart Museum enabled by default because I've gone ahead and given it the necessary flags. So here I've gone ahead and it's automatically generated the compose file. And if I say install, it's going to perform a few checks, verify if everything is in place, and it's going to try and figure out what else is necessary for it to be able to run my registry successfully, pull in all of those images as well. And very soon it should go ahead and spin up my Harbor registry with Trivy and with Chart Museum enabled inside it. So previously, if you remember from the architecture diagram of Harbor, right? So there were a bunch of things that were happening and quite a few moving parts. All of those have essentially been containerized. And in here, it's essentially pulling in all of those components which are going to be necessary. And it's going to be running our entire container registry as a bunch of containers, right? So that is what, uh, that is exactly what is currently happening right here. So here I can see that there is a Trivy adapter that's being pulled, chart museum that's being pulled, and so on. So now it's going ahead and creating all the networks, the containers, and so on, the volumes that are necessary. And with that container, it says Harbor has been installed and it has started successfully. So now if I run a Docker PS, I should now be able to see that there are a bunch of containers that are running by default. So this is where all the necessary, this is where the user interface is going to be running. I do not think I'm going to be able to access this on the Chrome or the Brave browser. If I remember correctly, it does cause certification issues, uh, like I just guessed. So what you can do is you can open up Firefox, and I'm going to be accessing Harbor on Firefox. Well, Firefox, which is a lot more friendlier for you to do potentially, uh, dangerous things. It allows you to do it. So I'm going to be able to access my Harbor instance. I'm just going to move my instructions to a different screen so that I don't have to keep going back and forth between multiple browsers. So my username is going to be admin, and my password, which was hard coded previously, obviously change it. In production is Harbor12345. And with that, I now have access to Harbor. Right. So in here, I can go ahead and start creating a new project. So I'm going to go ahead and create a new project. Bear with me for 1 second. I'm going to go ahead and create a new project called AppSecEngineer. I'm just hoping I have not made any typos there. All right, so I'm just going to copy it and paste it. Looks fine. I'm going to click on OK. And once this is done, from a lab instance, I should be able to perform a Docker login as well. So I'm going to come back to my lab instance and I'm going to do a Docker login. And in here, the username is going to be admin again. And the password is going to be Harbor12345. I'm going to copy, paste that in, and it's logged me in successfully. So with that, I'm going to go ahead and pull in an Ubuntu image. I'm going to go ahead and pull in Ubuntu 18.04, which is fairly old. And I'm going to go ahead and give it a new tag, right? So I'm going to rename this particular container image. And I'm going to say it's going to have my registry IP address, the port wherever it's running, AppSecEngineer val-image dot colon latest, right? So if I go ahead and do Docker images, I should have this image right here. So with this, I can go ahead and push my image by performing Docker push. And finally, once it's done, it's gone ahead and pushed successfully. I can head over to AppSecEngineer. I can see that there is a new val image that has been created. And if I want, I can go ahead and start scanning the image as well. Right. So with that, you can go ahead and start scanning the images. And this is how it's done. Right. So inside the container registry itself, you can go ahead and get started with scanning. And once the scan is done, it's going to give you, it's going to essentially tell us that, hey, you know what, there are 39 flaws in total, with 8 medium level issues and 31 low severity issues that have been found. So this is typically how you would go ahead and essentially run a scan from directly from your container registry. And with that, we have come to the end of this live stream slash workshop. Again, please do not forget to go ahead and sign up for that particular workshop with the sign up URL. You can go ahead and run these labs. And if you have any comments, queries, concerns, please feel free to reach out to us and we'll be more than happy to help you out in any way. With that, we have come to the end. Anish, are you still around?
Yep.
All right, perfect.
Yeah, so thanks guys for attending this live workshop. I really hope you've learned something new about container registries and container images. If you guys want to reach out to us, you can always join our AppSecEngineer Discord server. I'll link the Discord link, the invitation in our description, and you can reach out to us there. You can reach out to Nitin. You can reach out to our other instructor Abhay, and you can be part of the community. So that way you can actually start learning more about containers. We have an upcoming learning path on container security. So that's going to have 4 entirely new courses coming up in August. So that'll be some really exciting new content for you guys to enjoy. So I hope you guys learned something new and join us next month for a new live workshop, and we'll see you there. All right. Thanks, Nitin. See ya. Bye
Bye,
bye.
folks. Take care.